Welcome! Let's dive right into a topic that completely captures the imagination. Today, in this explainer, we're moving way past the sci-fi movies to uncover the actual, rigorous physics behind one of the most mind-bending ideas in modern science, parallel universes. Buckle up, because we're going on an incredible journey, not in a spaceship, but through the deep scientific theories trying to crack this massive cosmic mystery. Let's start with the ultimate pop culture fantasy. What if you could actually step into a parallel universe? Just imagine it, jumping through a shimmering cosmic portal and coming face to face with another version of yourself, a version who maybe made totally different choices in life. It's an amazing dream, right? That dream is exactly why we're so obsessed with stories about the multiverse. But there's a really harsh reality check here. The sci-fi expectation is that you just seamlessly step through some magical portal to an alternate Earth. The actual physics reality? It's all about impassable cosmic barriers. The brutal mathematics of real-world physics tell us that hopping between universes isn't just an engineering problem. Based on our current understanding, it's a physical impossibility. Direct travel is strictly prohibited by the laws of nature.
As you can see here, physics suggests that these magnificent multiple universes might actually exist side by side with ours in some vast cosmic tapestry. They might be separated by immeasurable distances in dimensions we can't even perceive, but the kicker? They remain fundamentally isolated. We might be neighbors in a multiverse, but the walls between these neighborhoods are absolutely impenetrable.
Section 1. Reality Check. Unstable wormholes. So, the most scientifically grounded concept we have for a cosmic shortcut is a wormhole. This is a theoretical bridge or tunnel right through the fabric of space-time. Theoretically, it could connect two vastly distant regions or even entirely different universes. It's basically a shortcut in the cosmic fabric, and it's the closest scientific idea we have to the portals we see in the movies.
But here's where the idea completely falls apart in the real world. Why does wormhole travel fail? Well, for starters, these structures, if they even exist, are highly unstable. We're talking prone to instant collapse. And even if we could magically prop one open, it might dump us into a universe with physical laws completely hostile to our biology. Not to mention the immense engineering challenges of creating or controlling something like this. They are way beyond human capability.
And that brings us to the absolute deal-breaker, exotic matter. To keep a wormhole from collapsing and crushing literally anything trying to pass through it, you would need massive amounts of this theoretical substance that possesses negative energy density. The massive problem here, we haven't even proven exotic matter exists in our universe, let alone figured out how to harvest it. It is the ultimate physical roadblock to the wormhole dream.
Okay, so if physically traveling there is impossible, what about just sending a text? Can we communicate? Let's look at the quantum realm. Quantum entanglement is this bizarre phenomenon where particles link up in such a way that the state of one instantly affects the other, literally regardless of the distance between them. Could we use this instantaneous connection to talk to a parallel universe?
It's absolutely crucial we clear up a major misconception here. Yes, entanglement provides an instant connection, but there is an ironclad cosmic rule called the no communication theorem. This theorem acts like an absolute unbreakable cosmic firewall. It flat out prevents us from transmitting any usable data or messages faster than the speed of light. So, sending a quantum text message to your alternate self? Sadly, that's impossible too.
Section 2. The pivot, looking for cosmic bruises.
So if both direct travel and quantum communication are completely off the table, what do we do? Well, scientists have pivoted. They've become cosmic detectives. Instead of trying to break down locked doors, they're looking for indirect clues, fingerprints left on our own universe. And the ultimate cosmic crime scene for these detectives is the cosmic microwave background, or CMB. This is the residual radiation, the oldest observable picture of our universe left over from the Big Bang. In this ancient cosmic canvas, astronomers are hunting for tiny distortions. Let's walk through how this creates a brilliant sequence of clues. Step 1. Picture these bubble universes constantly expanding. Step 2. In the deep, prehistoric past, our bubble universe actually bumps into a neighboring bubble. And Step 3. That collision leaves a distinct bruise, a permanent distortion on the CMB radiation. That is exactly what scientists are looking for, a permanent historical scar across our sky, proving we aren't alone.
Section 3. Hidden signatures, gravity's leaks.
That leads us to the next massive indirect clue in our detective story, the bizarre behavior of gravity. Check out this mind-bending quote.
Gravity is the only force capable of leaking across brains to the larger dimension, explaining why it appears so weak. This idea is just wild. It suggests our entire universe might be a 3D membrane, or brain, floating in a higher dimensional space. And gravity, unlike all other forces, is actually trickling away from our brain into extra unseen dimensions.
Have you ever wondered why gravity is so incredibly weak compared to electromagnetism? Like a tiny fridge magnet can defy the gravity of the entire Earth. The explanation might just be that gravity is interacting across hidden extra dimensions. If that's the case, unexplained gravitational pulls that we observe could actually be signals from massive objects in neighboring universes right next door. To investigate this, scientists are using high-energy particle colliders, trying to catch particles literally disappearing into these other dimensions.
Section 4. The Resolution, a Universe of Clues.
So, what does all this intense detective work mean for us? The big takeaway is that we might just be a tiny, small bubble in a vast, infinite cosmic tapestry. Realizing that our mighty universe, with its billions of galaxies, is possibly just a microscopic fraction of an unfathomable multiverse, it really decentralizes us, doesn't it? It's a dizzying thought, but it completely opens our minds to the infinite. I want to leave you with this profound thought to chew on. Even if we never figure out how to build that portal and we never get to cross over to meet our alternate selves, does simply knowing they might exist change our current reality? Searching for these hidden clues isn't just about exploring outer space. It's about fundamentally expanding the limits of human understanding. Reality, as it turns out, is so much stranger and more magnificent than fiction. Thanks for joining me on this explainer, and keep looking up.